All right, let's talk about async/await in C#. It's got to be one of the most powerful tools we've got, right? But it's also, easily, one of the most misunderstood. There's this one huge myth that almost everyone believes, and it leads to some gnarly bugs and performance nightmares. So today, we're going to bust that myth wide open and really dig into what's happening under the hood.
I bet if you ask any developer, heck, you've probably said it yourself, what AsyncAwait is for, you'll hear this. It's the classic line we all learn. Oh, it makes your code faster. And, it kind of makes sense on the surface, doesn't it? It feels right.
Yeah, well, it's completely wrong. And here's the kicker. Believing this isn't just a simple mistake. It's the root cause of some of the nastiest problems you'll find. We're talking serious performance bottlenecks, bugs that are a nightmare to track down, and even deadlocks that can crash your entire app.
Okay, so let's get to it. Time to shatter this speed myth once and for all. We're going to toss that idea out and replace it with the real truth behind async programming. And, spoiler alert, it has nothing to do with speed. It's all about capacity and being way, way more efficient.
This right here, this is the single most important thing to understand. AsyncAwait does not make one operation finish any faster. What it does is make your whole application more scalable. See, we're not chasing speed, we're chasing throughput. And the secret sauce is just this. It lets you stop wasting precious resources by not blocking threads.
So how does that even work, right? Let's pop the hood and take a look. That await keyword, it's not some kind of black magic. It's actually pretty clever, and we can wrap our heads around it with a really simple analogy. Let's talk about the non-blocking waiter. Okay, picture this. A blocking thread. That's like a really bad waiter. He takes your order, walks it to the kitchen, and then just stands there, doing absolutely nothing, twiddling his thumbs, waiting for your food to be cooked. Useless, right? Now the async waiter, that's the pro. She takes your order, hands it to the kitchen, and bam! She's off serving drinks to another table, taking another order, clearing plates. She is never just idly waiting. She's always being productive.
So that's the story. But here's the code reality. When your program hits an await keyword, it doesn't just hit pause. Instead, it does something really smart. It basically takes a snapshot of what needs to happen next. We call this a continuation. And then it tells the current thread, hey, you're free to go. That thread immediately returns to the thread pool, ready to grab another web request, process some other background job, whatever. The key is, it's not blocked. It's being put back to work.
And here we see the two approaches side by side. Over on the left, you've got the villain, result. This is a classic blocking call. The moment you use it, that thread is completely frozen in place. It can't do anything else until that one operation is done. It's an absolute scalability killer. But on the right, we have our hero, await. It frees up the thread, letting your app juggle way more work with the exact same resources.
All right, so now we get how it works. The next logical question is, when should we use it? Let's build a super simple playbook, because knowing when to use the tool is just as important as knowing how.
The number one rule is dead simple. Use async/await for anything that's I/O bound. What does that mean? Basically, anytime your code is just waiting around for something else to finish. Think about it. Waiting for a database query, waiting for an API to send back some JSON, waiting for a file to load from the hard drive. All that waiting time is the absolute sweet spot for async.
Now here's the flip side, and this is just as important. You have to avoid using async for CPU-bound work. If your code is doing heavy math or transforming a massive data set in memory, the CPU is running at full tilt. There's no waiting involved. The thread isn't sitting idle, it's actively working its tail off. Using await here doesn't help. In fact, it just adds extra overhead for no reason. If you do need to offload that kind of heavy lifting to, say, keep your UI from freezing, that's when you reach for task.run, a totally different tool for a different job.
Okay, let's get into what might be the most critical part of this whole thing. Look, knowing the rules is great, but avoiding the common traps, that's what really separates the senior devs from everyone else. We're about to cover the mistakes that can and will bring a production application to its knees.
So, let's break down the 3 deadliest async sins you can commit.
All right, deadly sin number 1. This is the big one. We've already established that using .result is bad because it blocks. But why is it deadly? Well, because in many cases, especially in UI apps or older ASP.NET, it doesn't just block. It causes a complete and total application freeze, a deadlock. So here's the insane trap it creates. Your UI thread calls .result on a task, right? So it blocks, waiting for that task to complete. Simple enough. But when the task finally finishes its work, it often needs to get back onto that original UI thread to deliver the result. And it can't. Why? Because the UI thread is still blocked waiting for the task to finish. It's this impossible catch-22. They're both stuck waiting for each other, and your application just freezes solid.
And the fix is actually a simple rule, a mantra you have to live by. Go async all the way. That means from the very top of your call stack, like your button click handler, all the way down to the database call. Every single method in that chain has to use await. You can never, ever mix blocking calls like .result or .wait into an async world. It just breaks everything.
Okay, deadly sin number 2, the siren song of async void. Oh, it looks so tempting, doesn't it? You don't have to return a task, it just seems easier. But it's a massive trap. People call it fire and forget. But the problem is, when something goes wrong, you can't catch the fire. An unhandled exception inside an async void method can just tear down your entire process. The rule is, avoid it like the plague, unless you are writing a top-level event handler, and that's pretty much the only exception.
And that brings us to our final sin, number 3, the broken chain. This really ties everything together. You can do everything right. You can have a beautiful, perfect chain of await calls, but if just one link in that chain decides to block by using .result, the whole thing comes crashing down. That single blocking call destroys the entire scalability benefit you were trying to achieve. It holds up a thread, and the whole system gets bogged down. It really is an all-or-nothing deal with async. So, you've done it. You've dodged all the traps, you've followed the rules, you've gone async all the way. What's the reward? What's the big payoff for all this hard work? Let's take a look.
Just look at these numbers. This is what it's all about. The time to finish one request, it's probably about the same. But look at the throughput, how many requests your application can handle at the same time. It's not a small difference. We're talking about a potential 10-fold increase. That's not speed. That is scalability. And what does that mean for you? It means you can serve way more users and handle way more data, all on the hardware you already have. So let's boil this entire thing down to one single golden sentence. If you walk away with nothing else, remember this. The next time you're in a code review, or better yet, a technical interview, and someone asks you about async/await, this is the answer that shows you truly understand it.
And really, that's the whole point, isn't it? Getting good at async isn't just about learning a new C# feature. It's a fundamental shift in how you think about building software. You stop thinking just about raw speed, and you start thinking about throughput, about capacity, about efficiency. So I'll leave you with this question. You've learned how to make your I/O non-blocking, but is your thinking still blocked?